All right, in this next example, same directions as what we've done on the first example, which is to review. We will be way up here. Set up and solve the definite integrals to find the total area of the regions bounded by the two curves. Sketch and shade an appropriate graph and then check using your calculator. So we began the example prior to this one on the previous video by finding out where these two functions intersect. I'd recommend doing that again here. So where do they intersect? We are going to set up a system of equations and solve for x and y. Now they're both equal to y, therefore they're equal to each other. Set them equal to each other. Now solve for x. So I'm going to get the terms both on the same side. I am thinking that factoring is going to be needed here. Factor out that common x. That's going to leave you with x minus 3x plus 3 equal to 0. You get 3 points of intersection. You get x equals 0, 3, and negative 3. So now is a good time to draw a graph so that you understand the bounds, how they work, why there's 3 bounds for one thing, and then which function's on top and which function's on the bottom. So if I sketch the graph of y equals x cubed, it's going to go something like this. If I sketch the graph of y equals 9x, it's going to be a straight line that hits the origin, has a positive slope. So it's going to go something like this. And notice that there's 2 separate regions of area. There's a region right here and there's a region up here. They are symmetric, but you may not realize that at this stage of the game. So we're not going to use that symmetry fact to solve. The straight line, once again, was your function g, and the curved function was function f. So did you notice that on the first part, this piece of the area, the curve function's on the top, and the linear function is below. And then when you crossed over the origin, now the linear function's on top and the curved function is below. And so we have to compute the total area, which is why if you scroll back up or go back to your first page of directions, it'll say calculate the area of the regions by setting up definite integrals. So there's a plural statement there, meaning you might have to do this in 2 steps. I won't make you do more than 2, right? So we're going to set up the integral for the red area first. Now the intersection point is at negative 3 and 0, and then while we're at it, this one over here is at 3. That was the purpose of solving where the 2 systems are equal to each other. Now, the red integral, we'll go ahead and use the red pen for this. It's going to go from negative 3 to 0, and then the top function, once again, is x cubed, and you're going to subtract the bottom function, which is 9x. Now that's going to give you the red area. We want the total area, don't we? So we're going to add the blue area, which is going to go from 0 to 3. And now the top function is the 9x, and the bottom function is x cubed, and that's with respect to x. So we're going to work this out in 2 pieces and then add each piece together. So we're going to get x to the 4th over 4 minus 9x squared over 2. This section is going to be evaluated going from the bottom, negative 3, to the top of 0. The next integral will give you 9x squared over 2 minus x to the 4th over 4. In this piece, the bottom bound, lower bound is 0, and the upper bound is 3. And if you work them out, you're going to get a total answer equal to, we'll go in 2 pieces, 20.25 plus 20.25 for a total area of 40.5 square units. That's going to be both pieces combined. Example 3, we have 2 functions. G is going to be a parabola opening down. F is a linear function. And so we need to figure out where they cross. Where do they intersect? So we're going to set them equal to each other because they're both equal to y. And now we can solve for the x coordinate, the point of intersection. I'm going to move everything to the right-hand side, so that makes my x squared positive. So that's going to be positive x squared, and then a minus 15x, and then a plus 36 equals 0. And now I can factor this to solve for x. You have to remember your factoring skills. No time to forget any of that. Let's see, factors of 36 that add to negative 15. I might think about 9 and 4. That's no good. 2 and 18. That's no good. 3 and 12 looks pretty promising. How about minus 3 and minus 12? So I get 2 solutions, 3 and 12. Those are my 2 points of intersection, x-coordinates of those points of intersection. Now you're going to want to draw a sketch, and feel free to use a graphing calculator if you would like to at this stage. Let's see, the function g opens down, the y-intercept is at -8, so let's draw something like that. And then function f is a line, the y-intercept is at +28, not too high, that's too high. Let's put it right about here. And then, oh wait, I messed that up. I have it backwards. Yes, it is high. And then it goes down at a negative slope. So we're going to be doing something like this. I don't know. Good enough, right? And so the points of intersection are what we want to label, 3 and 12. Okay, and so the area that we're calculating is this piece inside from 3 to 12. So the top function is the parabola, that's the g function. G is on top, and then the linear function is on the bottom, right? G's on top, F's on the bottom, yes. Okay, good. So we're going to integrate from 3 to 12. 3 to 12 of the top function, g of x, so -x squared plus 10x minus 8, minus the bottom function, which is -5x plus 20. I'm using parentheses because when I subtract that bottom function, I've got two things to subtract, not just one. So let's go ahead and simplify that a little bit. So -x squared, what next? 10x plus 5x is 15x, and then -8 minus 28 is minus 36. So this is what I'm integrating, and I end up getting -x cubed over 3 plus 15x squared over 2 minus 36x, and this gets evaluated from the lower bound of 3 to the upper bound of 12. Plugging in the top number minus the bottom number, you end up getting a quantity of area equal to 121.5. So I'll leave the calculator number crunching for you to check on your own. In the last example, we have two parabolas. They both open up. I want to find out their points of intersection, or at least just the x-coordinates of those points. Set them equal to each other. And then solve for x. So move everything to one side. It's quadratic, so we can solve by factoring. By the way, if it doesn't factor and it's quadratic, you can use the quadratic formula. Let's see, factors of -15, let's see, 5 and 3, 5, 3, 3 and 5, how about a 3 here and a 5 here? And I have to have a sum in the middle of +1, so this has to be positive, and I forgot my x, and that has to be negative. So let's do a FOIL to check. So 2x squared, 6x, minus 5x, minus 15, looks like it works out. So I get 2 points of intersection. The x-coordinates are 5/2 and -3. By the way, if you did want to know those y points of intersection, you would just plug in each of those numbers back into either function, g or f, and figure out the y-coordinate. When you're graphing these functions, I would recommend using your graphing calculator at this stage of the game. It's a little less obvious how these are going to run. Something like this is your function f. And function g goes something like this, okay? And this is the piece of area that we want to calculate. The points of intersection go from -3 to 5/2. So label those on your picture as well. Set up your integral. So I need to see all of these steps when you're working this type of problems out for the test. If you choose to take that next test on the May 1st, I do need to see all of these steps. All right, now the top function we said was f, right? So 2x squared plus 5x plus 4 on top, minus the bottom function, 4x squared plus 6x minus 11, and dx is our variable of integration. And I can distribute the negative sign and combine some like terms. 2x squared minus 4x squared is -2x squared. 5x minus 6x minus x. And 4 plus 11, 15, with respect to x. You end up getting -2x cubed over 3 minus x squared over 2 plus 15x. This goes from -3 to 5/2 Plug in the numbers in your calculator, the upper limit minus the lower limit. Work it out, check my answer, 55.46 is what I got.